In this construction, you're going to learn how to take a given segment and divide it into a given number of congruent parts. In previous constructions, you learned how to take a segment and divide it in half using the perpendicular bisector construction. And with a perpendicular bisector, that would allow you to cut things into fourths, eighths, sixteenths, etc. But what if you wanted something different, like cutting things into thirds, fifths, sevenths, etc.? There is a construction for that. So this particular construction, I'm going to show you how to divide a segment into 3 pieces. So we're going to divide into thirds. But we can adapt this so that you can ultimately use this for any sort of division you would need to do. So the first thing we're going to do is we're going to go ahead and draw a ray AZ. The ray can be of any length, it can be at any angle, so long as you have it. I'm going to go ahead and draw this nice long ray. I'm going to label it here at the bottom as point Z. Now, we are going to go ahead and cut this into 3 pieces. So we are going to go ahead and mark off points R, S, T using any radius so that AR is equal to RS, which will also be equal to ST. So the number of points you mark off will determine how many pieces you can cut the segment into. So again, I can use any radius here. So again, I'm going to use A as my center. We'll call that R. Then the intersection of my ray and R, that'll become my center. Mark that off. Then we'll transfer it down here to what I will essentially call S. And we can mark this as well. And that will give me at least 3 congruent segments, AR, RS, and ST. From this point, we're going to go ahead and construct segment TB. And what that'll do is that'll create a triangle out of points A, T, and B. What we'll do from here in order to get our congruent smaller segments is we are going to go ahead and create parallel lines to segment TB because those parallel lines will help create congruent segments. So we're going to use the parallel line construction that you learned earlier in the unit. And we're going to go ahead and do this 2 other times, so that way we have lines parallel that go through point S and also through point R. Now, in order to do that, we need to be able to copy angles. So we're going to go ahead and use that construction. We're going to copy angle T. We're going to copy that arc here at point S. And I'm also going to do the same thing at point R, because we're going to need it at all of these spots here in just a bit. It's okay if, especially that point closest to A there, if your arc goes a little bit above the given line, that's okay. Again, we're just copying these arcs however they turn out. Now, again, we're continuing to copy the angles here, so we want to measure at angle T here, the width. Again, looking at from point to point here where it intersects the angle itself, as you can see. Okay, we're going to go ahead and make a little marking for that. And then I'm going to transfer that over to the arc that was formed next to from point S. And then do the same thing up top here. Make that arc as well. Now, once I have those, I can go ahead and connect point S to where the intersection of these arcs occurred. And then do the same thing at R. So what that will do is create 2 other lines that are parallel to segment TB. Now what I'm going to do here is I'm going to label these points of intersection here So I have a frame of reference. I'm just going to call them C and D. Once I have those parallel lines drawn in, I can also mark them as parallel if I want. I can go ahead and say that these segments here are congruent to one another. So I could say AD has the same measurement as DC, which also has the same measurement as CB. We could also say that they are congruent to one another as well.